November 23, 1987, Homer Airport, Alaska. A Ryan air charter commuter plane carrying a hunting party crashes on landing. 18 of 21 on board are killed. The official NTSB ruling cites weight and balance as the cause of the accident. On December 12, 1985, an Aero Air DC-8 military charter departed Gander, Newfoundland, carrying servicemen returning to their families for the Christmas holidays. A crash after takeoff killed 248 soldiers and 8 crew members. While an official ruling on the exact cause is still pending, it is believed that a reported 12,000-pound cargo weight discrepancy was a major contributing factor. These are not isolated occurrences. Hundreds of incidents resulting in injury and aircraft damage have been attributed to weight and balance problems.
Hi, I'm Captain Bill Barsley from the Flight Department. The purpose of this video is to discuss the importance of your job as it relates to each flight. Accurate load information is very important. It is used to calculate aircraft performance data used throughout the flight. If the pilot receives inaccurate load information prior to takeoff, the entire flight will be adversely affected. The total weight of an aircraft is made up of the following components: the weight of the aircraft itself, the payload, and fuel. The total weight is used to calculate performance data. During a flight, the weight of the aircraft is constantly changing because the engines are burning fuel. As a result, the aircraft is much heavier at takeoff than it is at landing. All flights can be divided into 3 phases: takeoff, en route, and approach and landing. Now let's take a look at how weight and balance affects each phase of flight. The takeoff phase of flight is very critical. Many critical takeoff decisions are made using the reported weight and balance information. First, the pilot must select a runway long enough for the planned takeoff weight. Then, takeoff power and optimal flaps are selected. The optimal flap setting provides the flight with the best possible safety margin during takeoff. This will minimize the amount of runway used while maximizing climb performance, which may be required to clear obstacles. If the actual weight of the aircraft is higher than the reported weight, a runway that is too short may be selected. The result of choosing a runway which is too short would result in an accident like this.
Just go out of runway up. Got an engine failure on one. Just go out of runway. You want to get it stopped? It's American 123. We're off the end of the runway. We need to fire the equipment.
During the takeoff roll, the pilots are concerned with 3 airspeeds, which are all computed using the reported weight of the aircraft. The first is takeoff decision speed, or go-no-go speed. If an engine failure occurs during the takeoff, the decision to stop or continue the takeoff is made using this speed. If an engine fails at or below this speed, the takeoff is aborted and the aircraft can be stopped on the remaining runway. If an engine fails above this speed, there isn't enough runway left to stop, but there is enough runway to continue the takeoff. The second speed is the rotation speed. This is the speed at which the pilot begins to fly the aircraft off the ground. The third speed is takeoff safety speed. This is the minimum flying speed the pilot maintains if an engine failure occurs after passing the go-no-go speed. All 3 of these critical speeds are calculated using the total weight of the aircraft. If the reported weight is inaccurate, these critical speeds used by the pilots will be wrong. During an emergency, the pilot could make an incorrect decision or take an incorrect action because of inaccurately reported weight. Let's talk about the balance of the aircraft. The actual location of the payload weight is also very important. It is used to determine the center of gravity. The location of the center of gravity directly affects controllability of the aircraft. For example, if the center of gravity is out of predefined limits, the aircraft may not be able to fly at all because of being too nose heavy or too tail heavy. The location of the center of gravity determines how the cockpit is set up for takeoff. During a normal takeoff, the amount of runway used is minimized and climb performance needed to safely clear obstacles is maximized. With a cockpit set up incorrectly, the aircraft will either leave the ground late using too much runway if it is nose heavy, or leave the ground prematurely at too slow of an airspeed, possibly causing a tail strike if it is too tail heavy. Both could potentially result in reducing obstacle clearance to zero. Now that we have reviewed the takeoff considerations, let's take a look at the en route phase. Accurate weight information is needed to select the optimum cruise altitude and airspeed to minimize fuel burn. If the aircraft is actually heavier than the reported weight, the aircraft may not be able to reach its optimum cruise altitude. This could potentially result in an air traffic control conflict, perhaps even a near mid-air collision, as flights routinely climb through altitudes of other oncoming aircraft with a closure rate of over 1,000 miles per hour.
Descend, descend, descend.
There are situations which require the pilot to change cruise altitude. It may be necessary to climb to the aircraft's maximum altitude in order to avoid bad weather or turbulent air. For example, if the top of a thunderstorm is extending above the flight's current cruising altitude, a climb to a higher altitude would allow the aircraft to safely overfly the storm. If the actual weight of the aircraft is heavier than that reported, the aircraft may not be able to reach the desired altitude. A wrong decision could be made unless the pilot has accurate weight information. The result could potentially be hail damage or a lightning strike to the aircraft or injury to passengers and crew caused by turbulence. The location of the center of gravity is also important during the en route phase of flight. The center of gravity is constantly changing throughout the flight because fuel is being consumed at a rate of 100 to 200 pounds per minute, depending on aircraft type. A properly balanced aircraft is an efficient aircraft. If the center of gravity is forward or aft of the optimum position, the pilot must compensate using flight controls. This increases aerodynamic drag and increases fuel consumption. We have discussed the takeoff and en route considerations. Now let's take a look at the approach and landing phase. Prior to landing, the pilot must determine if the runway being used at the destination airport is long enough. The heavier the aircraft, the faster the approach speed, and the longer the runway must be. Approach and landing speeds are calculated using the total weight of the aircraft. The approach speed is the most critical because the aircraft is slowed to its minimum flying speed. If the approach speed is calculated using an inaccurate landing weight, the approach speed may be too fast and the selected runway may not be long enough. Conversely, if the approach speed is too slow, the aircraft controllability may be adversely affected.
Next fire. Lower your nose, you got stick shaker.
Both present potentially dangerous situations. An accurate landing weight is required to ensure a safe approach and landing. The location of the center of gravity is also critically important. If the center of gravity is too far forward, the aircraft may be too nose heavy to complete a safe landing. If too far aft, a controllability problem could exist during the approach, preventing the pilot from maintaining a stabilized approach speed. The pilot could potentially lose control of the aircraft and land short of the runway. As you can see, the information you provide for a flight is extremely important. Many critical decisions are made during each phase of flight. The accuracy of the weight and balance information is essential to conducting a safe flight. Without this information, all of these decisions would be invalid. A margin of safety is engineered into each flight using the weight and balance information provided by you. The pilot depends on accurate weight and balance information. We know that when an emergency situation arises, the margin of safety is narrowed. The information on the closeout must be correct the first time, every time, since it is so critical to the safety of the operation. And it's set 4 up. 4 It's armed. 0 at 0. Left. Right. 10. All for 10. 10 degrees and takeoff.
Verified.
Verified. Flight control. The brake. Check. Then check.
It's on and check. Cleared into position and hold.
Ladies and gentlemen, we have completed our cockpit checks with our flight attendants. Please prepare for takeoff. Okay, engine control. One way up. Flight attendants have been ready.
Cleared for takeoff.
Here we go. Maximum power, 101. That's good.
Power set. 80 knots.
Come on, baby.
Using a lot of runway up. Got an engine failure on one.
Let's use a lot of runway.
You gotta get it stopped.
We're not.
Not a nose gear flap. Los Angeles Tower. It's American 123. We're off the end of the runway. We
Still
need
on fire.
emergency equipment. We got a fire. What you've just witnessed is a simulation of an aircraft accident caused by inaccurately reported weights. After the engine failure, we were unable to stop the airplane on the remaining runway, resulting in a nose gear collapse. Had we known of the additional weight, this accident could have been prevented. Just as you trust us when you or your family takes a flight, we trust and count on you to properly load the airplanes and accurately report weights for safe flight operations.
You've just seen the consequences of not doing the job properly. They are without a doubt devastating. To perform this function requires a team effort. We have agents, equipment service, and load control involved. Each group has specific responsibilities in determining weight and balance and load planning. We put a lot of responsibility on each of your shoulders to perform these procedures flawlessly. It's truly a team effort, but no one can do your particular function except you. So as you go about loading aircraft or providing the data to load control, we ask that you perform these functions just as we've laid them out in the procedures, that you do them accurately, consistently, and in the case of data input to world flight, as promptly as possible following the loading of the aircraft. We look to you to perform these functions every day absolutely perfectly to avoid the devastating consequences that can occur when we deviate from our procedures.